Welcome students to another lecture on real analysis, in which we shall prove that the function f of x equal to sine x is continuous for all a real number. We shall prove this result by delta epsilon definition. First we discuss delta epsilon definition of continuity. A function f of x is said to be continuous at point C if limit x approaches to C, f of x is equal to f of C, which implies for any epsilon greater than 0, there exists a delta greater than 0 such that if x minus C mod is less than delta, then f of x minus f of C mod, f of C whole mod is less than epsilon. This is delta epsilon definition of continuity. Now we apply this definition to prove this result, that this function is continuous for all a real number. Let C belongs to R be any real number. We shall prove that f of x is continuous at this point C. For this we have to prove that limit x approaches to C, f of x is equal to f of C. Now we apply delta epsilon definition, for which we suppose that x minus C mod is less than delta, and this is our equation number 1. Now f of x minus f of C mod can be written as this is equal to, as f of x is equal to sine x, this is equal to sine x minus sine C mod whole mod. Now as we know that we have a formula that sine x minus sine C is equal to 2 times sine x minus C by 2 cos x plus C by 2 whole mod. Now we have some other relations that we can use here. The first one is, as we know that sine x mod is always less than or equal to 1. Similarly, cos x mod is less than or equal to 1. Here we try to find a relation between delta and epsilon. For this we need a relation between delta and epsilon. Now we have another relation that sine x mod is less than or equal to x. Now we use these relations to establish a relation between delta and epsilon. Now this can be written as 2 times. Now sine x minus C by 2, by using this relation we can write this is strictly less than, this is less than x minus C upon 2, as sine x mod is less than or equal to mod of x. Similarly, cos x mod is less than or equal to 1. Now we use this relation that cos x mod is less than or equal to 1. Why we are using this relation for cos, not for sine? Because we need a relation between delta and epsilon, and we know that x minus c mod is less than delta, as x minus c is the argument of sine. That is why we are using sine x mod is less than or equal to x. Now we do not need a relation like x plus c. That's why we are using cos of x mod less than or equal to 1. We use these relations according to the situation. Now situation demands that we need a relation between delta and epsilon, and x minus c mod is less than delta. We need a term in term of x minus c. Now we can cancel out 2 and we have x minus c whole mod. Now by using equation 1 we can write that x minus c mod is less than delta. Now if we choose delta equal to epsilon, that if we choose delta equal to epsilon, then we can write, as on the left hand side we have sine x or f of x minus f of c, which is f of x minus f of c, which is equal to sine x minus sine c. F of x minus f of c, which is equal to sine x minus sine c whole mod. This is less than epsilon because delta is equal to epsilon. Now for any epsilon greater than 0, we have a delta greater than 0 such that whenever x minus c mod is less than delta, then f of x minus f of c mod, which is sine x minus sine c mod, is less than epsilon. Now by delta epsilon definition we can write that, which implies f of x, or we can write it as limit x approaches to c f of x equal to f of c, or we can also write it as or limit x approaches to c sine x is equal to sine c. Now this relation shows that f of x equal to sine x, which implies f of x equal to sine x is continuous at x equal to c. As x equal to c is an arbitrary real number, because c is an arbitrary real number, which implies f of x is continuous for all real number. Implies f of x equal to sine x is continuous for all a real number, which completes our required result. Thank you very much for watching this video lecture.